Okay, ladies and gentlemen, welcome to the beginning of the real party. When it comes to Chapter 5, we're going to start verifying these trig identities and doing proofs, algebraically, of course. The biggest thing about proofs is you have to remember that you're not solving an equation, so you're not allowed to, add 3 on both sides or divide both sides by sine of theta, all of that stuff. You can't do that here. We're trying to prove that the left-hand side of the equation is the same thing as the right-hand side. So you can make substitutions, you can factor, you can cancel. As long as you're doing it on one side only, there is no true solving here. You got to get that out of your little brain. You see it equals, but it does not mean we are solving an equation. We are proving an identity. Okay? Some strategies provided. It is almost always easier to start with the hard side and try to turn it into something easier than it is to do it the opposite way. You can also start on the left-hand side, work for a little while until you get stuck, and then start on the right-hand side and also work until you get stuck. And oftentimes the place where you get stuck, they'll match. So you can work from both sides until they match. Don't forget that you can factor, look for a substitution, do the adding, do the subtracting, especially if you have fractions. It's a great idea to find common denominators to combine fractions. You can rationalize, you can multiply by a conjugate. But if everything else fails and you're left just completely bewildered as to even where to start, change everything into sine and cosine. Definitely not the easiest way to do things, but for a lot of students it's the only way they can get it accomplished because you're just not used to thinking in terms of secant. Okay. There are a few different ways to approach number 1. I'm actually going to redo number 1 a couple of times. And again, folks, I am not going to sit here and make a 45-minute video on this. I have answer keys. I can post them. I can share them. I can let you take pictures of them or copy them in class. My job here is to encourage you to not be afraid to mess up. And I'm even going to show you one of my mess ups, if you will. And I did the proof, and the proof is done, and it's great, but it's done in about 8 steps. And then when I looked back at it again, I realized that I can do it in 4. So that happens as well. It's all good. Number 1, you see sine squared x minus 1 divided by sine squared x equals negative cotangent squared x. Remember, you cannot multiply both sides by sine squared x. We are not solving, we are proving. You might notice the numerator on the left-hand side looks really close to a Pythagorean identity. It is not. Do not stick a cosine squared x up there. That is wrong. But what you can do, if you want, if you are just like, I have got to use a Pythagorean identity here, you can factor out a negative 1. Think about what happens. So I'm going to start over here on the left-hand side. I'm going to factor out a negative 1 from the numerator. That's going to leave me with a negative sine squared x and a plus 1. And then on the bottom, I still just have sine squared x. Okay, and then it equals the right-hand side. You do not have to continue to copy the right-hand side. It's not necessary. Okay, well, that looks like it made things worse, but now look at this. 1 minus sine squared x, that is cosine squared x. And when I multiply it with that negative 1, I have a negative cosine squared x, right? There's a negative 1 on the outside, and then I still have my denominator of sine squared x. Still have my right-hand side over there. Wait a second. Cosine squared x divided by sine squared x is cotangent squared, right? And a negative in front makes this a negative cotangent squared x, which is equal to the other side. Woohoo! I'm done. And I almost always tell my students to put a check mark, put a happy face, go ahead and rewrite the other side equals. Make some kind of a note on your paper so that you know you are done with the proof. Nothing is more annoying than to think that you're finished, but you got stuck and you actually moved on, and then later you realize that you didn't actually finish your proof on your test and you lose points. Not cool. Okay, now what I'm going to do is I'm going to pause the video and erase all this and show you another way to do the problem that I just did. Give me a moment. Alright, starting completely over. Let's say that you didn't see the Pythagorean identity because, you knew it wasn't exactly equal to cosine squared theta, and so cosine squared x, excuse me. So maybe you were like, can't even use that, what else? Take a look again at your fraction on the left. You have two things being subtracted in the numerator, but your denominator is only one term. So what you could have done instead, you could have split this up into two separate fractions. Your first fraction would have been this right here. What is sine squared x divided by sine squared x? Okay, well, again, I'm starting on the left-hand side here. So I could have written this as sine squared x divided by sine squared x. And then the second fraction would have been this right here. And so I would have had a minus 1 over sine squared x. Okay, and then it equals the right-hand side. That's legal. Remember, think about it. If I have, 2 minus 7 over 3, that's the same thing as 2/3 minus 7/3. Either way I go, I still end up with a negative 5/3. Okay, so that's legal. You can do this. And why do we even do it? Well, let's look at what we have. Anything divided by itself is 1. And then this second one, well, that is a reciprocal identity, right? 1 over sine squared is cosecant squared. So this is 1 minus cosecant squared x. And then it still equals the right-hand side. But again, hold the phone and wait a second. This right here is equal to negative cotangent squared of x. How do I know? Because it is an identity that has been rewritten. You have to learn your identities, ladies and gentlemen. Walk around with them. You've got a snapshot. You've got your notes. You can write them, wherever you need to write them. You will not get to use them on the quiz or a test, but you have to become familiar with using them. Okay, let's see. What's next? 2, 3, 4. Kind of need to work all these. All right, let's speed it up a little bit. Number 2. The most difficult side appears to be the right-hand side simply because it's a fraction, It's easier to work with regular quantities than fractions. You could, again, try lots of things. I think for this one, I'm going to rewrite tangent and secant in terms of sine and cosine and see what happens. Alrighty? So, starting with the right-hand side, I'm going to leave this as 1 over, what is tangent? Well, we know tangent is sine x over cosine x, right? So that's sine x over cosine x. And then secant, what is secant? That's 1 over cosine of x. Cool. Well, remember what this whole 1 over thing right here even really means. It means the reciprocal, right? So instead of thinking this as a nasty, ugly, complex fraction, I can just take each piece on the bottom and flip it over. So this is really like just cosine x over sine x. Multiplied by, that's a multiply, not a minus, I'm sorry, cosine x over 1. Oh, but wait a second. Now some of you may even want to go, ooh, cosine x times cosine x is cosine squared x, yes, and cosine squared x divided by sine x, and yes, I'm done. And then you look at the the left-hand side, and you see that, no, actually they don't match. Slow down. Always work towards the other side. Don't just simplify crap for the heck of it. You have a goal here. You have an objective. Our objective is to make the fraction 1 over tangent x secant x look like this guy over here. Nothing else. Just that. So if you take a moment and recognize, here's cosine of x, here's cosine of x. What? I'm mostly done. Is cotangent of x equal to this right here? It sure is. That is cotangent x, cosine x, and my sides match. Okay, so before you just, do math for funsies, and, I personally am a fan of doing math for funsies, make sure you're working towards your goal. Always keep that other side in mind. I'm going to pause it, move things up. Number 3 is nasty in comparison to 1 and 2. Which one looks more difficult? Probably the one on the left. The one on the right does contain a minus sign, but the one on the left contains cotangent and cosecant, and no one likes them compared to sine. And we also have that squared value on the left. So I'm going to start with the left-hand side, and I'm going to recopy it here. Cotangent squared theta over 1 plus cosecant theta. Okay, and that's going to equal my right-hand side. But I'm looking at this, and I'm looking at this, and I'm trying to think about what to do, and I just, where can I go? What can I do? When you have two fractions, and you see on the bottom of one of them is a plus, and the top of the other one is a minus, one of the only ways, or just about in this particular class at this level, the only way that you can get those signs to be swapped is to multiply by the conjugate. What is that? Well, we talked about it briefly in class. It is just a fancy fraction. It's kind of like the idea of rationalizing. When we rationalize, we're really just multiplying by 1. But it's a very fancy special one that accomplishes a need that we have. It's a means to an end. It lets us reach our goal. We need to get rid of that plus sign on the bottom. I also completely need to make the whole 1 plus cosecant theta piece go away. If I multiply by the quantity 1 minus cosecant theta on the top and the bottom, this is called the conjugate. Remember that a conjugate is the exact same expression with an opposite sign in the center. Why would we even do this? What is the point? Well, observe the denominators for just a second. If we take 1 minus cosecant theta and we multiply it with 1 plus cosecant theta, we're going to be left with 1 minus cosecant squared theta. It's almost like a difference of squares, if you will. So this right here, when multiplied together, gives me 1 minus cosecant squared theta. Okay? What about the top? Well, top is a little bit of a mess. I mean, let's admit for now. We have this quantity right here, 1 minus cosecant theta, and it's being multiplied with cotangent squared theta. And then, of course, we still have our right-hand side. Looks like we made things worse. But wait just a moment. Hold on. This I recognize. I recognize this on the bottom. 1 minus cosecant squared theta, that's almost cotangent squared, right? Yeah, almost. It's actually negative cotangent squared. So I'm going to make that substitution. I'm going to leave my numerator alone. I haven't gotten to it yet. I tend to take things very slow. Folks, if you're awesome and this is super duper fun for you and you see all these little shortcuts and you can start combining steps, go for it. Pretty confident I'll be able to follow your work. For the rest of us, we're just going to take it slow, step by step. Okay, and then we still have it equal to the right-hand side. We haven't gotten over there yet. I'm not worried about him. I'm trying to match him up, remember? Ooh, hey, look at that. We have a cotangent squared on the top. We have a cotangent squared theta on the bottom. Ooh, anything divided by itself is gone, right? It cancels out. It divides to 1. So I can kind of divide those babies out. And I'm left with 1 minus cosecant theta over a negative 1. Please don't cancel those negatives out and say the answer is 1 plus cosecant theta. That's just bad math. That's going to end you up in jail. Where do I go from here? Golly gee willikers. Well, here we go again, right? We have 2 parts in a numerator and just 1 denominator. So maybe I can split it up again into 2 separate fractions. Maybe I can think of this guy right here as being a fraction. So 1 divided by negative 1 is a negative 1, right? I've kind of run out of room here, and I hate to put equals like this, but I don't have the space right now. And then I could do this guy right here A negative divided by a negative is a positive, and I'm left with cosecant theta. Well, that doesn't seem to help me much, but remember, my whole goal here is to end up at sine. And I kind of do have sine now, because cosecant is 1 over sine. Yeah, so I have -1, and then I can rewrite the cosecant as 1 over sine theta. Cool. But it still doesn't match. Oh, I know what I can do. I can take this whole entire thing and I can multiply through by sine of theta. Now, why am I doing this, folks? I'm just putting these guys over a common denominator. You know, you would multiply the first one by sine theta over sine theta, and you multiply the second one by pretty much nothing. Sorry about that. My phone buzzed. So when I do this multiplication, I end up with the negative sine of theta plus 1 over sine theta. That's the answer. Take a look at it. You don't believe me? Let's look. This guy right here, on top, I have a negative sine theta and a plus 1. What do I have over here? Ooh, I have a negative sine theta and a plus 1, but they're written backwards. What do I have on the bottom? Sine theta. At this point, I'm technically done. If you would like to rewrite it so that it matches exactly, that's never a bad idea, but at this point, you are done with the proof, and I can see that the sides match. Okay. Other ways to do this? Absolutely. First time I did it slightly different, but again, I'll skip a step or two, but this is ultimately the way that I did it straight away. Taking a look at number 4, you might think that the right-hand side is the toughest side, but I don't know. I kind of think that since the power of 4 is on the left, that's going to be a lot worse for us. That's actually a difference of squares. We could think of this as a difference of squares question. Let's try that. We can take this side right here and do 1 minus sine squared x times 1 plus sine squared x equals the right-hand side. Well, why did I do that? Oh, hey, I know. That's because 1 minus sine squared x, that is cosine squared x. I know my Pythagorean identities. That's cosine squared. And what about the other guy? Well, I don't know what it is yet. I'll get to that in a second. Sine squared x equals the other side. But wait a second. I need everything in terms of cosine squared, right? 1 plus sine squared x, guys, that's not a Pythagorean identity. There's no way you're going to be able to end up with 1 plus sine squared theta on the same side, ever. But what you can do, you can take the actual sine squared theta portion and make a substitution there. Okay? So I'm going to leave the cosine squared x in red because that was my first piece. And then I'm going to leave the 1 plus part in green. And equals the right-hand side. But then I'm going to rewrite sine squared of x in terms of a Pythagorean identity. How would I do that? Well, sine squared x is a lot of things, but it's 1 minus cosine squared x. So 1 minus cosine squared x. Now those of us that are awesome see that we're now done. But the rest of us, we can go ahead and write it out. We have a 1 plus a 1 minus cosine squared x, right? 1 plus 1 is 2. So we are left with a cosine squared x on the outside like this. And then we have a 2. And then we have a minus cosine squared x on the inside. Does that equal the right-hand side? Doggone right it does. We're done. This video is turning into something much longer than I typically like to record, but I want to do 2 more on this side. And again, if you want to see the rest of them, I can show you my answer key in class. I'm certainly not trying to hide it from you. I'm just saving time. Number 6. Number 6 is a classic question. They'll change the sines and secants to be any of the 6 trig functions, but it is not uncommon for them to have 2 fractions being added together equal to a single quantity on the other side. The best way to do this is think of this as got to find the least common denominator, add them together, and then see what happens from there. Okay? So this is what I'm going to do. I'm going to take the left-hand side, and I'm going to kind of spread it out and rewrite it here for a minute. And then I have the plus, and then I have 1 over 1 plus sine x. Now, ladies and gentlemen, I am not here to teach you how to add rational expressions. If you need assistance on this, stay after with me one day, find a video, or go back to your math 2 or 3 teacher. Okay? Look at your 2 fractions. Your least common denominator is the quantity 1 minus sine x times 1 plus sine x. The first fraction, what is it missing? What does it need? It needs 1 plus sine x. So I'm going to multiply it by 1 plus sine x. Look at the second fraction. What is it missing? What does it need? It needs the quantity 1 minus sine x. I am technically multiplying by that value on the top and the bottom, but again, this is a little bit of a shortcut. I am not here to teach you how to do this. I am here to simply remind you of this. When I put all of this together, I end up with these 2 multiplied plus these 2 multiplied as my numerator. Since I'm multiplying by 1, quantities don't really change, right? So my whole entire numerator is, and then of course it equals the right-hand side still. I forget that sometimes, my apologies. 1 plus sine of x plus 1 minus sine of x all over 1 minus sine x times 1 plus sine x. And then it still equals the right-hand side. Awesome. Look at your numerator. You have a positive sine x being added with a negative sine x. Bye. It's gone. Adds to 0. So the only thing on your numerator is a 2. 1 plus 1 is 2. Look at the bottom. You have 1 minus sine x times 1 plus sine x. 1 minus sine x squared. Or sine squared x. I should have said it as sine squared x. My apologies. Oh, hey, I know this. 1 minus sine squared x? Yeah, 1 minus sine squared x, that's cosine squared x. So this is actually 2 over cosine squared x. And I know what that is. Since I know that 1 over cosine squared x is secant squared x, this is just 2 secant squared x. And I'm done. It matches. Number 8 was the other one that I wanted to talk about briefly. Number 8 plays out similar to number 6, but there is a different way that you can do it. And you can certainly start on the right-hand side, play with all the fractions and everything else, and that's doable, but that's not really ideal. Take a really close look. Actually, hold on just one second. I'm going to push this out of the way, push this up some, give myself a little more room. Take a look at that right-hand side again. We know the reciprocal identities, right? We know that 1 over cotangent to the 4th of a is really just tangent to the 4th of a. And we know that 1 over cotangent squared of a is really just tangent squared of a. Sweet, the fractions are gone. Well, what did that do for me? Well, nothing yet, right? Nothing yet. But I do have a tangent squared in there, and I know that tangent squared and secant squared a are related through a Pythagorean identity. But that 4th power, that just bothers me. Ooh, you know what? I have two quantities being added together that contain a like factor. Maybe I can do a GCF here. If I think of a tangent squared A as being the GCF, and I pull that out, I'm left with a tangent squared A plus 1. It doesn't seem like it accomplished very much at all, but in actuality, it did. What is tangent squared A plus 1? That's right, that is secant squared A, folks. So we have tangent squared A times the quantity secant squared A. Well, you may be thinking that this is actually a terrible, terrible thing, and it didn't help me because I have a secant squared A, but my final answer, again, remember, we're always working towards the other side, it has a minus sign, and there are no tangents. Oh, there are no tangents. Okay, well, why don't we take tangent right here and rewrite him as secant? We can do that, right? We know how to substitute tangent squared of A. We can use a Pythagorean identity. Tangent squared A is secant squared A minus 1. So again, we have the left-hand side. We're not touching it. We can make a substitution here. This can be secant squared A minus 1. And then we still have secant squared of A over here. Ooh, distributive property. Work it out, guys. Do the distributive property. Multiply these two, multiply those two, and I think it matches. Secant squared A times secant squared A is secant to the fourth A, and then negative 1 times secant squared A is a minus secant squared A. Do the two sides match? Darn tootin' they do. Alright, again, I'll provide the answers to the other two in class if you need them, but I'd really like to see you work them out and give them a try. We are just going to keep attacking this in class for the next couple days.